Yeah, so Hunter is with AWS and working with deep learning in the cloud. So tools for training and deploying models at scale. And so we'll look at some of the frameworks and libraries that he used to work on supporting cloud native geospatial. And yeah, looking for training and ML models. So should be very interesting. So take it away.
Yeah, all right. Hey, can you hear me? Sorry about that.
Yeah, no problem.
All right. And can you all see my screen here with this slide
Yeah,
deck shown? All right, fantastic.
you're titled
So,
by now.
all right, awesome. So my name is Hunter Carlisle. I'm a senior data lab architect in the AWS Data Lab. And the work that I do in the AWS Data Lab exposes me to a lot of different customers and use cases all across the kind of ML domain. But in particular, we often will work with folks trying to, work with geospatial data sets and techniques in the deep learning space. And so, this talk kind of came out of conversations I had with customers around, what sort of support is available right now in the different, open source tools and frameworks that are available for doing deep learning. What sort of support is available for these geospatial data sets? So as we look at some of the challenges that people face, working with these data sets is cumbersome. I think a lot of the benefit we get out of the cloud native file formats is, being able to work with these massive data sets in a little bit of an easier way. But when you're training models on top of them, the complexities tend to rise. A lot of domain expertise is required in order to properly work with the data. You need to enrich the data, usually with additional information, in order to build a meaningful machine learning model. The more features and data available, the better. And finally, the exploratory analysis and kind of visualization tooling is often a little bit limited, as we've seen, and as you probably all know. So when we look at the different frameworks that are available here, I'll kind of keep it higher level here. We won't get too deep into the technical specifics, but in general, most of the major frameworks support working with geospatial, cloud native geospatial data formats, such as COGS, or they generally support them pretty well. PyTorch in particular has a geospatial extension called TorchGeo that really makes our lives a lot easier. So with TorchGeo, you can generally work with most of these file formats without too much difficulty. MXNet and TensorFlow, in addition to some others, they don't necessarily have modules or extensions. There are some that you can find if you kind of dig around, where they're kind of created by individual users or something, but they don't kind of have that first-class support like we see with TorchGeo. But that is kind of rapidly evolving. But in general, they still support working with these file formats, generally through different third-party libraries. And you've probably seen some, as the conversations have gone on during this event, and there will be some discussion on that, in later talks in this event as well, what some of those libraries are and how you can work with them. But in general, it's not a painless process to work with these frameworks and do serious deep learning on top of these geospatial file formats. You often have to do a lot of conversions, and you have to think very hard about where and how you're storing the data to stage it for training. But in general, the prognosis is good, and it's getting better, right? All of these frameworks, and there's a couple others that aren't represented here that also generally play pretty nicely with these file formats. And a lot of that, that is really a function of the strength of these formats, and the clever and innovative things that are happening with these format standards that are making it easier and easier to interoperate and work with these libraries. There are a couple other helpful tools and libraries that often come into play as well, and I won't get too deeply into this because I know the next talk after mine kind of will touch on these as well. But there are a couple. So here, Open Data on AWS allows you to kind of share and build services on top of your data sets using various AWS resources. There's actually a talk later this evening or actually tomorrow afternoon from Mike Jeffy at AWS as well, that is diving into this deeper if you want to learn more about that. Raster Vision is an open source framework for Python computer vision models based on geospatial satellite aerial imagery data sets. So that's a great library as well that can provide if you're doing stuff in the vision domain with those raster files. Radiant ML Hub is a stack spatiotemporal asset catalog, stack catalog for different Earth observation data, as well as models that are trained on those data sets. So that's another good place to look for some resources there. Then you've got GeoPandas, the extension of the Pandas library for geospatial data. The Apache Sedona project really unlocks some of the integrations with things in the Apache domain and the Hadoop domain. So Spark, and other tools like that it extends kind of Spark data frames into the geospatial domain. And then finally Onyx, which is the open neural network file format, interchange file format for representing those models. I'll kind of close here with a call to action. We need better tooling at all stages of this process, from the exploratory analysis, feature engineering, and data set creation, model training, and deployment as well. So, please absolutely get involved. There's lots of opportunities to contribute to these and make the process less painful and more efficient and really help unlock better insights. And we like to work backwards from use cases and applications. So if you're building something, start with what you're targeting and then work back. And as you end up building out these tools and building out these things, think about contributing to the libraries and the packages there. So thank you. That is all. I know the timing is a little off. Hopefully I didn't take too much time there, but please reach out to me if you have any questions. I'll take a look at the Gitter if there are any additional questions as well. But you can find me on Twitter or LinkedIn if you want to connect there. I'd be more than happy to chat and yeah, go from there. All right.
All right. Yeah. Thanks, Hunter. Maybe real quick, I'm just curious. You mentioned it's not painless to work with the deep learning frameworks. What's some of the common intermediate formats you have to use to integrate with them?
Yeah. So in general, most machine learning frameworks are going to be structured around kind of the underlying kind of NumPy arrays, right? So most of your input records and formats, they need to kind of get converted into some sort of an array structure at some point. But that's where some of the tooling is not as well developed. When you're working with kind of raster files and image files and getting them into that kind of numeric input structure can be a little bit cumbersome, a little bit challenging. Like I said, there are some tools, and that's where you kind of rely on some of the different open source and available Python processing frameworks and libraries to help make that a little bit better. But yeah.
All right. Yeah. Well, thanks a lot, Hunter. That was great. And maybe at the very end, if we have any time for Q&A,
yeah, absolutely.
But